Hello, welcome back to MLT 110. We're going to be doing some review worksheets for Unit 3 dealing with ABO and blood typing. Both the worksheets that we're going over today are going to be posted in Moodle, so if you want to print them off and follow along as we go through these worksheets, you can do that and you can get them from Moodle. So on this first ABO review worksheet, we're going to be focusing on what's going on inside the body. So inside the body, we do not want any agglutination to happen. So if we scroll down and look at this guy that's on the left-hand side here, this circle is going to be representing our red blood cells, and this Y figure is representing our antibodies. The Y figure roughly represents what an antibody looks like. So if this person on the left-hand side of our worksheet was a type A person, what type of antigens would be stuck to the red blood cells? Again, if this person is type A, they would have A antigens stuck to their red blood cells. Okay? If they have A antigens stuck to the red blood cells, what would be their naturally occurring antibodies in the body? It would have to be B antibodies. And where do we find the B antibodies? They're found in the plasma. Okay, now let's go over to the example on the right-hand side. Let's imagine if this person was a B type. What type of antigens would they have on their red blood cells? They would have B antigens stuck to their red blood cells, correct? Okay, what naturally occurring antibodies would they have? They would have A antibodies. And that would be, or those antibodies would be found in the plasma. Let's go to the next page in the next example. What would the antigens be on a person with A B blood? The person with A B blood would have to have A and B antigens on their blood cells, correct? Well, now let's think about their antibodies. We do not want any agglutination inside the body, right? So the AB blood type can't have any antibodies in their plasma. So no antibodies. Okay, now let's talk about the O-type person. What type of antigens would they have? Could they have A or B on their red blood cells? No, they would not. So they would have naturally occurring A and B antibodies in their plasma. Again, we do not want agglutination happening inside the body. Up to this point, we've been talking about what's going on in the body and not wanting agglutination happening in the body. But now we need to kind of switch gears and talk about testing and the reaction with the reagents in blood banking. In testing, though, we want agglutination or need to have agglutination to help determine blood type. So let's look at this example. So we have a tube here with patient red blood cells in it. And then we have our reagent, which is anti-A, and that's representing antibody A. And then, of course, we have the pellet here in the bottom of our tube that's representing agglutination. So that means that we have added the reagent, antibody A, to our patient red blood cell, and we've ended up with agglutination in the tube. So if we have antibody A and it mixes with the patient's red blood cells and they cause agglutination, what type of blood do you think the patient has? We have type A blood, or a patient with type A blood, because if you have antibody A and you have red blood cells with A antigens on it, you're going to get agglutination. Now, this person, this type A person, they would have naturally occurring B antibodies in their body because we don't want agglutination. But when we're testing and we need to find out what type a person is, we add the opposite to the blood sample in order to get agglutination, so we know what blood type they are. We need that reaction. We need to see agglutination. So we take the red blood cells, we add antibodies to it, and if it agglutinates, we know what type of antigens they have. So if they agglutinate with antibody A, we know that there's A antigens on those red blood cells. So this person would be a type A. So let's look at another example. Here's another example. For this example, we again have agglutination in the tube because we have a pellet. Again, these are patient red blood cells in our tube. And our reagent over here is antibody B. Okay, so we're adding antibodies to our patient red cells to see if we can get a reaction or agglutination, and we did. So if we're adding antibody B to our red cells, then we know we have B antigens stuck to those red cells. So this person would be type B. Let's look at some more testing examples. We are going to read straight across. This is one patient right here. This is anti-A representing antibody A has been added as a reagent. This is antibody B, meaning antibody B is being added as a reagent. We haven't talked about anti-D or the D control yet, but anti-D or would be representing helping us determine whether it's RH positive, or RH negative. If it is positive, then the patient is RH positive. If it's negative or no agglutination, the patient would be RH negative. And the control we always run, and your D control, you always want it to be negative. If it ends up being positive for some reason, there's something wrong with testing, and you're going to have to start troubleshooting or rerun all your testing, because if your control comes out to be positive, something has went awry somewhere. So your control should always be negative. So let's see if we can read across and see if we can come up with a blood type for this patient. So anti-A is negative. The squiggly line is representing a negative reaction, no agglutination, and the dot is representing a pellet representing agglutination. So with anti-B, we have agglutination. Anti-D, again, which is representing our RH, looks like it's agglutinated, which is going to mean a positive reaction, or a RH positive. And then our control is negative, which it should be. So it looks like this person has antigen or B antigens on the red blood cells. So this person, I would say, is a B positive blood type. Okay, let's go down to the next example. we have agglutination in anti-A, agglutination in anti-B. We also have agglutination in our anti-D, which is represented on RH, and of course our control is good. So we have antigens on A. The red blood cells have A antigens on them. They also have B antigens on it, and they have the RH antigens. So this person is AB positive. Okay, next we have a positive reaction or agglutination in anti-A. Then our anti-B is negative, our anti-D is negative, and then our control is negative. So this one person would have A antigens on the red blood cells, making them a type person, and the RH is negative, so they would be an A negative type person. Let's scroll down. Remember, this is your anti-A, anti-B, the anti-D, and our control. It looks like we have negative reactions in our anti-A and anti-B. We do have a positive reaction in our anti-D, and of course our control is negative. So if we do not have antibodies, or excuse me, antigens for A or B on the red blood cells, we're left with that patient has to be an O type. And that RH is positive, so this patient would be O positive. Now we're going to switch gears and we're going to start working on our second worksheet. The name of this worksheet is MLT 110 ABO/RH practice worksheet. Again, this worksheet should be posted in Moodle if you want to print it out and follow along. So let's look at question number 1. Known anti-X is used to test the population of Morganton. 65% of the population's red blood cells test positive with anti-X. Given the information and assuming that the antigen X and Y follow the same rules of the ABO blood group, answer the following questions. And before we go on and answer the questions, this problem or this question usually always trips students up. So let's look at the information given just a little bit closer. Remember, anti is referring to antibody. Antibody X is used to test the population of Morganton. And 65% of the red blood cells test positive with antibody X. So keep that in mind. So let's look at the question, or question A. What percentage of the population has antigen X? Okay, and if it's following the same rules as ABO, so let's think about this. If this was an A patient and we were to test it with antibody A, okay, we'll just replace A with, or the X with A. If the percentage of the population has antigen A and we tested with antibody A, what percentage would have it? 65%. Because if there is a positive test, that tells us if we add antibody A, or in this case, antibody X, and we have a positive reaction or an agglutination, that means there's antigen X in this case, which would be the same thing as antigen A if we plugged A in there, on the red cells of the patients in Morganton. So this is 65% right here. The next question would be, what percentage of the population would produce anti-Y if exposed to the X antigen? This is kind of a trick question because if it's following the ABO or the same pattern as the ABO blood grouping, if 65% of the population we know has antigen X, then what would there naturally occurring antibodies be? They would have to have antibody Y already. So 65% of the population would already have antibody Y naturally. So to sum it up, 65% of the population would have X antigens on their red blood cells, and that same 65% of the population would have antibody Y in their plasma. Let's look at number 2. Highlight the correct answer in parentheses for the statement. In patient samples, the antibodies would be found in the plasma or red blood cell. We know that is plasma. And the antigens are found in on the red blood cells. Number 3, if a patient has only antigen B present in his blood, his antibody would be, again, only antigen B present in the blood, so the antibody would have to be anti-A. Okay, number 4, if a patient has antibodies A and B, she has antigen what? None. So what blood type would they be? Type O. Okay, number 5, if a patient inherits an A gene and an O gene, he will be what type? Type A. So let's go on down and look at number 6. Can 2 type O individuals have a type B child? And let's explain. The answer is no. The explanation is that O is a recessive gene. So both parents would have to have inherited O from their parents in order for the gene to have been expressed in them as a dominant blood type. Therefore, those parents would have only the O gene to pass to their child, meaning they could not have a B type child. Now let's look at number 7. It has a Punnett square. It says, what are the possible offspring blood types of a heterozygous A type and a homozygous B type? So we already have our Punnett square laid out. We have our A and O across the top for our heterozygous A type, and our homozygous B, our BB, down across the left-hand side. So it's just a matter of filling it out. So we have A, B, it's a possibility for offspring. We have BO, it's another possibility. We have another AB, and then another BO. So those are our possible offspring for that crossing of parents. Number 8, if a patient is found to have antibody A, what antigen would they have? So that they have naturally occurring antibody A in their plasma, what antigen would they have to have on their red blood cells? We know we want the opposite in the body, so they would have to have antigen B on their red blood cells, because we do not want agglutination in the body. So number 9 says, review the results of the forward and reverse type and answer the questions. So in the chart, it gives you results for forward type on the left-hand side. And again, our patient sample is patient red blood cells. And on the right-hand side, it's the reverse, and we're going to be using the patient's serum or plasma. So they're using the reagents anti-A and anti-B, and then our RH and our RH control for the forward. In the reverse, you would be using A cells and B cells as our reagents. So let's go ahead and look at 9A at the question. What is the patient's blood type, the ABO and RH? Okay, so we can see they tested with anti-A, and you have a 4+, which indicates a positive reaction. So if you have agglutination and a positive reaction, with the anti-A or the antibody A, that tells us automatically that there is A antigens on the red blood cells, correct? So we can go ahead and put down A. There was no reaction with anti-B, it's negative. So there's no B antigens on those red blood cells. So the RH is negative, so there's no RH antigens on those red blood cells, so it's negative. And the control is negative, so the testing is good. And the reverse should echo the opposite of the forward typing. So let's just check to make sure. This is a positive result, so this should be a negative result in reverse. This is a negative result, so it should be a positive result in the reverse, and it is. This is saying that with the antibodies in the plasma was tested against known red blood cells containing antigens. Red blood cells that had antigens A, it was negative, and when it had red blood cells with B antigens, it was positive for the plasma. Okay. Number B, 9B, what antigens does the patient have in their blood? We've kind of already discussed that. We know they have A antigens on their red blood cells because they are type A, and we had a positive test here. What naturally occurring antibodies does the patient have in their blood, or we could say their plasma? We know they have antibodies or anti-B in their plasma, right? Number 10 is the same scenario as number 9. They give us results to review, forward and reverse results, and ask us some questions. First question is, what is the patient's blood type for ABO and RH? Again, we're going to look at our anti-A first. It looks like it's negative, so that tells us there's no A antigens on the red blood cells, and it is confirmed with our reverse type. Anti-B is a 4+, so we have B antigens on the red blood cells. Our RH is positive this time, so it looks like we have a B positive patient. Which antigens does this patient have on their red blood cells? We already mentioned that patient has B antigens on the red blood cells. What naturally occurring antibodies does this patient have in their blood? They're going to have anti-A. 11A, this is another situation where they're wanting to know the patient's blood type, ABO and RH. This test for anti-A is negative. It is also negative for anti-B. So this person must be an O, and it's confirmed in the reverse type with the opposite reaction. The RH is a 4+, so that tells us it's a RH positive patient. So what antigens does this patient have? This patient has none. Remember, to be an O-type patient, you cannot have any antigens on your red blood cells. But in your plasma, you can have A and B antibodies. Now let's look at our last example, number 12 on this worksheet. Again, we're reviewing the results of the forward and reverse type, and we're going to determine the patient's blood type. We have a 4+ reaction in the anti-A, a 4+ reaction in the anti-B. So that automatically triggers us to start thinking a B blood type, and it is confirmed in the reverse with the opposite reaction. In our RH, our reaction is negative, so this would be an AB negative person. What antigens does this patient have on their red cells? they would have A antigens and B antigens on their red blood cells. What naturally occurring antibodies does this patient have? These patients or this AB person couldn't have any antibodies or no antibodies in the plasma. This concludes our worksheets on ABO and RH for blood banking. I hope these worksheets helped and help reiterate some of the concepts. If you're still struggling or need help with anything, please don't hesitate to reach out. And I will see you guys next week in class.